The next part of our lesson is 6.1, and it's going to be on simplifying a rational expression. First thing we need to know, what is a rational expression? It's just a fraction that has algebraic terms in it. And last week I gave you a sheet that looked like this, and we're going to be doing this first part right here. Writing a rational expression in lowest terms. That's simplifying. That's the same thing. It says first we need to factor the numerator and the denominator, and then we're going to divide out common factors, and there's a special note here that we'll come back to in a minute. We won't need that just yet. I am working on page 420 in section 6.1, and I'm starting with problem number 41. When they're just single terms, there's no adding and subtracting, then you can just divide out like terms. So I can say 6 will divide into 6 one time, and 6 will divide into 18 3 times. And this r, which is an r to the first, I subtract the exponents. So that's going to give me an r squared in the numerator. So in the numerator I have 3r squared. The denominator is just a 1, so I don't need to write that. So that's my final answer. Now you use that method when it's just single terms, monomials it's called. Now we're going to go to number 43. And this one's already factored for us. And we can divide out common factors, so that divides out. And then what can we divide into both of those? We can divide a 2 into that and get 2. And 2 into 10 and get a 5. So my answer is 2/5 because that divided out completely. Now I'm going to go to number 47. And this is where we'll first use these strategies that we just talked about, where we're going to factor the numerator and denominator. So from the numerator, I can factor a common factor of 7. And from the denominator, I can factor a common factor of 5. And when I have now factored those out, I have a common factor of m plus 2 that will divide out. There's nothing that will divide into 7 and 5, so that becomes my answer. Okay, now we're going to number 55. We're going to factor the numerator and the denominator. Remember, we always start with common factors. So from the numerator, I can factor a common factor of 3. And from the denominator, I can factor a common factor of 4. This is the difference of squares. It's a binomial with a minus, and they're both perfect squares. So that means I can factor some more. So I do the sum and the difference. Then I'm just going to copy the denominator. Now I can divide 2m minus 1 out. Nothing will divide into 3 and 4. So I can leave my answer as this in factored form. Or if you want to distribute that 3, you could write your answer like that as your final answer. Either way would be acceptable. It's important to know that when you're dividing out binomials, they must match exactly. In other words, I can't go in here and divide out part of this with part of this. or I can't divide out this minus 1 and this minus 1. When it's in parentheses as a binomial, it's got to be the entire thing or nothing at all. Now I'm going to problem number 69. Okay, this leading coefficient's a 1, so I'm just looking for two numbers that I can multiply to get negative 15 and combine to get a positive 2, which would be a positive 5 and a negative 3. In the denominator, again, the leading coefficient's 1, so I'm just looking for two numbers that I can multiply to get a 5 and combine to get 6, so that would be plus 1 and plus 5. Now, you can divide out the x plus 5 with the x plus 5. But like I was just saying, these don't match exactly, so you can't like divide out the x's. That doesn't work. It's the whole binomial or nothing at all. So my final answer looks like that. And that's the simplified form of the answer. Now, sometimes the factoring is a little more complicated. Let's look at problem number 71. Because this leading coefficient is not a 1, I'm going to need to do my x. So 2 times negative 5 is negative 10. I'm going to copy the negative 3 and look for numbers that I can multiply to get negative 10 and combine to get negative 3. That would be a negative 5 and a positive 2. So I'm going to copy the 2x squared. I'm going to replace the minus 3x with minus 5x plus 2x, and I'm going to copy the negative 5. Then I'm going to factor by grouping, and from the first two I can factor out an x. And if I copy the 2x minus 5 down here, I ask, what do I multiply this by to get this? That would just be a plus 1. So then I factor out the 2x minus 5, and I'm left with an x plus 1. So this numerator, it took me all of this to figure it out, but I'm going to go ahead and write it down here at the bottom in factored form. 2x minus 5 times x plus 1. That's my numerator. Now I'm going to work on the denominator. So I'm going to make my x for my denominator. 2 times positive 5 is a positive 10. And I'm going to copy the negative 7. So two numbers that I can multiply to get a positive 10 and combine to get a negative 7 would be a minus 2 and a minus 5. So from the denominator, I copy the 2x squared. I replace the minus 7x with that, so minus 2x minus 5x, and I copy the 5. Now I'm going to factor that by grouping. So from the first two, I can factor out a 2x. I'm going to copy my x minus 1 down here and ask, what do I multiply by x to get negative 5x? That would be a negative 5. I'm going to copy my x minus 1, or not copy it, but factor it out. And I'm left with 2x minus 5. 2x minus 5 is my other factor. And I'm going to bring that way back down here and put it under this, because remember that was my numerator. And now this is the factorization for my denominator. Now, the 2x minus 5 and the 2x minus 5, they match, so I can cancel those out. These don't match. So my answer is x plus 1 over x minus 1. Okay? So we have to remember our factoring strategies from everything we've learned about factoring in order to simplify these fractions. Now, there's one little catch to this part, and I said that the factors have to match exactly in order to divide them out. Well, there is one difference, and that is if they're exactly the opposite. If you look back at your handout, I made a note that a minus b is equal to negative 1 times b minus a. If you multiply negative 1 times that, you will get a minus b. In the same vein, x minus 3 is negative 1 times 3 minus x. And 5x minus 6y is negative 1 times 6y minus 5x. Notice that in all three cases, the second factor is the first factor reversed, but they're both minus signs. So if we will go to page 421, and we're going to look at problem number 99. Now, I kept saying that you can only factor things out if they match exactly. Well, the exception to that is if they're exactly opposites. 6 minus t, t minus 6. When that happens, you can divide them out, but instead of getting 1, you get negative 1. And since that's all that's left in that problem, that becomes my final answer. Let's go to number 101. Sorry, let me see if I can stop that phone from ringing. Okay, so the numerator, remember we factor the numerator, factor the denominator. The numerator is the difference of squares, so I can factor it m plus 1, m minus 1. And I'm going to copy the denominator because it can't be factored. Now, these are not opposites. To be opposites, they have to both be minus signs. So, m minus 1, 1 minus 1, 1 minus m. Those are the opposites. So, I can divide those out, but I get negative 1. So, my answer is negative 1 times this m plus 1, which I can just write as minus m minus 1. Let's go to number 103. Common factor of q and common factor of q. Now, this q will divide out this q because they match exactly. These two are opposite, so they will divide out, but you get negative 1. So, in my numerator, I have negative 1. My denominator, I have positive 1. So, my final answer is just negative 1. So, you can only do that, this negative 1 business, when they're exactly opposites. And that's what I was trying to help you understand in that special note. Alright, you should now be ready to do the homework assignment on section 6.1.